So let's examine the following example in which we're going to use the ideal gas law to determine the total mass of air inside a given container. A certain container has a volume of 600 meters cubed and is at standard pressure. Now, the standard pressure is simply 1 atm, which is equivalent to 1.013 times 10 to the 5 newtons per meter squared. What is the total mass of air inside the container at 25 degrees Celsius, assuming that air is composed of 80% nitrogen and 20% oxygen? So let's begin by using the ideal gas law. The ideal gas law states that pressure times volume of our container is equal to N, the number of moles of gas, multiplied by the universal gas constant R, multiplied by temperature in Kelvin T. Now, we know what R is, we know what T is, and we know what P and V is. So we can solve for N, the number of moles of gas. So N, the number of moles of gas inside our container, is equal to the ratio PV divided by RT. Now, the pressure given in newtons per meter squared is 1.013 times 10 to the 5. The volume is given to be 600 meters cubed. The constant R is 8.314 joules per mole times Kelvin, and the temperature in Kelvin is 25 plus 273, which is 298 kelvins. So we plug the values into our calculator and we get that the number of moles inside our container is approximately equal to 24,500 moles. So we know that 80% of this number is equal to the number of moles of nitrogen, and 20% of this value is equal to the number of moles of oxygen. So to calculate the number of moles of oxygen, we simply multiply 0.2 times this value and we get 4,900 moles of oxygen. Likewise, to find the number of moles of nitrogen, we take 0.8 and multiply by 24,500 and we get 19,600 moles of nitrogen inside our container. Now notice that we're dealing with diatomic oxygen and diatomic nitrogen. That means if we want to calculate the total mass of our oxygen inside our system, we have to find, using the periodic table, we have to find the mass per mole of our oxygen, which is 16, and multiply that by 2, because in diatomic oxygen we have 2 oxygen atoms. So 32 grams in 1 mole of diatomic oxygen multiplied by the number of moles of oxygen, 4,900, gives us 156,800 grams of oxygen. And to convert this to kilograms, we divide by 1,000 and we get 156.8 kilograms. Now, to find the total mass of nitrogen, we find the mass or the gram per mole of nitrogen, which is 14, multiply that by 2 because we want diatomic N. So 28 grams in 1 mole of diatomic nitrogen is equal to, or multiplied by 19,600 moles, is equal to 548,800 grams. So we convert this to kilograms and we divide by 1,000, we get 548.8 kilograms. So to calculate the total mass of our air inside the container, we simply add up these two quantities. So 156.8 kilograms plus 548.8 kilograms gives us 705.6 kilograms is the mass of air inside our container.